Hi, algebra. So today our lesson is similar to yesterday's. We're still going to be graphing those U-shaped parabolas, but we're going to add a couple steps. Okay, so the idea is the same. It's going to be a little bit more challenging today. So bear with me. Try your best today, and we'll see how it goes. So we're going to be able to find the vertex and the axis of symmetry, and we're going to plug back into our table to graph our parabola. So that will be the same. So we got some new vocab words. Well, actually, they're not that new because we've talked about domain and range, just not in this context yet. But the domain is the set of all possible inputs or x values. So we talked about that, I think, all the way back in November. But whatever I plug into my function is called the domain. The range is whatever answer I get when I plug into my function. So all the possible y values. So we'll see what that looks like when we're talking about a quadratic graph. So we're given these two graphs and we need to answer all these questions about it. But for the most part, up until we get to domain and range, it's what we've already done. So remember, our vertex is either the high or low point of our graph. So on this first one, that point is right here. And we can see that it is over 2, down 3. So my vertex is 2, 3. Is it a maximum or a minimum? Well, we can obviously tell that it's the low point of our graph because nothing's beneath it down here, so it is a minimum. Our axis of symmetry is that line that cuts our parabola in half. So that blue line I just drew in, and remember it's always x equals, what's x equal right here? 2. And remember it's the same number as this guy. Same thing. Now our domain. So what are the possible x values we can plug into our t-charts that we were making yesterday? Well, no, it's easy about the domain, guys. It's always all real numbers. It's never going to be anything different. So if you can remember that it's going to be all real numbers, you're good to go. Because I can plug in any single value and I'll get something out. And our range is a little more tricky, but it's going to be y. So now what can my y values be? I'm going to erase this for a quick second. Do you see how there's nothing happening beneath this point right here? My graph is all going upwards like this. So y has to be greater than, well, what's this value right here? -3. Oh, guys, it's -3, my bad. -3. So I know that y has to be greater than or equal to -3. But what's kind of nice about your range, as it's this, I'm going to grab a different color, it's this number goes right here. Okay? We'll let that sink in. We'll get some more experience with this in just a second, but that's kind of the gist. Okay, let's try another one. So our vertex, remember, is either the high or low point, and that's happening right here. What is that point? Well, it's over 3, up 7, so -3, 7. Is it a max or a min? Well, it's at the top of my graph, so it is a maximum. Our axis of symmetry, so if I draw in that line here, I know it's going to be x equals, what's x equal here? Well, it's -3. Again, it's the same number as this guy. Our domain, don't think too hard. Our domain is always all real numbers. And our range, so remember it's going to be y something. Now I look, nothing's happening up here, my graph is going downward, so it has to be less than what? What's this number? 7. So y is less than or equal to 7. And again, that number is always the same as this guy. These are the same. Okay, so that's the first thing that's kind of new today is that domain and range idea. Okay, now let's see this next part. So it says to find the x value of your vertex of a quadratic function, we use the following formula. So -b over 2a. That is how you find the x value. So negative b over 2a. I'm sure you're thinking, well, what the heck? What's this negative b and 2a talking about? Well, yesterday in our notes, we wrote down that this is our standard form of a quadratic function. So if I were to plug in some numbers here, let's say it was 2x squared plus, oh, I don't know, 4x plus c. Oops, not c. We'll do 5, whatever. So let's pretend this was my equation we were given here. Well, if I look, well, what's my b here? Well, let's line it up. B is that 4. So I'd have negative b, so what's opposite of a positive 4? It would be a negative 4. All over 2 times what's my a value? If I look, this is my a value right there, so 2 times 2. And then you can simplify. So I'd have negative 4 over 4, which really is negative 1. We'll get really good at that today, but just know that's where those numbers are coming from. But just please star this negative b over 2a. I put 2 big stars here. Highlight it if you need to. You're going to use it a lot from here on out for the rest of the chapter. Okay, so now graphing's going to look slightly different today. We're not going to always plug in those same 5 numbers we did yesterday. We're going to have to plug in maybe some different ones. So we have nice little steps to follow when we graph our quadratic function. So it says, first find the axis of symmetry. Well, how am I going to do that? How we're going to do that, guys? Negative b over 2a. That's going to tell me what my axis of symmetry is. So how about you write that right here? Negative b over 2a. That's what step 1 is. So if we look here at my equation, negative b. Do I even have a b value here? Do I even have a b? No, I go from my a value to a c value. So actually my b is a 0 all over 2 times, what's the a? Negative 2. And now we're going to simplify that. So I'm going to get 0 over negative 4, which is just 0. Okay, so I just found that our axis of symmetry is x equals 0. Perfect. So that's a start. And we know that this 0 is the same as my vertex. But now how am I going to find that y value? Well, it's easier than you think. All we have to do is plug into our equation over here. So if I do that, I'm going to have negative 2 times 0 squared plus 3. And now you can use a calculator to crunch this out, or you can do it by hand. Whatever you want to do works for me. But I know that 0 squared is just 0 plus 3. Negative 2 times 0 is 0. 0 plus 3 gives me 3. So now I found that my vertex is 0, 3. Now we're going to make our t-chart. I try to give you as much space so you can just kind of organize this how you want on your notes. But we have to make our t-chart. And I know my vertex is at 0, 3. So now I'm going to pick some values from here. So 0, so I can pick it a 1, 2, and I can do negative 1 and negative 2. I know these are the numbers we used yesterday, but that won't always be the case today. Okay, so I'm going to plug in the positive values because I think that's just easier in my brain to do. So now you're just going to plug in. So we've done step 2, find the vertex. Now we're going to fill in our table by using a calculator or doing it by hand. So if I plug in a 1, I'm going to have negative 2 times 1 squared plus 3. Well, 1 squared is just 1, so I have negative 2 times 1 plus 3. Negative 2 times 1 is negative 2 plus 3. Well, negative 2 plus 3 is just a 1. So I know I have a 1, 1. And remember, this number is the same as this guy right here. Perfect. So far, so good. Now he's got to find one more number. So if I plug in a 2, let's see what we get out. So again, I'm going to have negative 2 times 2 squared plus 3. Negative 2 times 2 is 4. Plus 3. Negative 2 times 4 is negative 8. Plus 3. And then negative 8 plus 3 is negative 5. So again, if this guy down here is negative 5, so is this guy right there. So now we can finally bring this over to our graph and graph it. So I have 0, 3, 3, 1, 1, negative 1, 1, 2, negative 5, and negative 2, negative 5. So my points check out. I'm good to go. We can connect it. And there's our parabola. Okay, now let's finish this out. Domain. Remember, our domain's always all real numbers. And if I look at my range, it's going to be y. So now that we have to decide, is it less than or greater than? So is it happening above or below? All my numbers are below this amount, so it's less than or equal to 3. And again, it's the same as this number right here. I know this is a lot of information and I'm not here to help you and I feel really bad about that, but just try follow along the best you can. Okay, let's try one more. So again, step 1 is to find the axis of symmetry. How do we do that? By doing negative b over 2a. So I'm looking at my equation over here, and here's my a value, there's my b value, and here's my c. So if I plug in negative b, so negative just means the opposite. So if I already have a negative 6 right here, what's the opposite of a negative 6? Well, that would be a positive 6. All over 2 times, what's my a value? It's 3. And then if we simplify, have 6 over 6. And 6 divided by 6 is just a 1. So I found our axis of symmetry is x equals 1. And I know that the x value of my vertex is a 1. And again, how do I find that y value? We just plug in. So now I'm going to plug this 1 into our equation. So I'm going to have 3 times 1 squared minus 6 times 1 plus 2. Now some of you I know can just punch that into your calculator. If you're comfortable doing that, go ahead. But I'll just work it out in here since you can't see that I have a calculator. So 1 squared is just 1. So I'll have 3 times 1. Negative 6 times 1 is negative 6 plus 2. Negative 3 times 1 is a 3 minus 6 plus 2. Now if I add those numbers together, 3 minus 6 is negative 3 plus 2. Negative 3 plus 2 gives me a negative 1. So we just found our y value to be negative 1. Okay, so we just did step 2. Can check that off. Now we need to fill in our table. So if I make our t-chart over here, so this is where it's going to be different. Do you guys see how my vertex doesn't have a 0 with it? So my vertex is really 1, negative 1, and now I fill in my values from here. So what comes after 1? A 2, and then a 3. And then on the other side would be a 0 and a negative 1. Okay. So let's plug in, to find out for 2, let's plug in a 2. I'm going to go like this for a quick second. There we go. So if I plug in a 2, I'm going to have 3 times 2 squared minus 6 times 2 plus 2. Now we're just going to work it all out. 2 squared is 4, so I'm left with 3 times 4 minus 6 times 2, negative 12 plus 2. 3 times 4 is 12. 12 minus 12 plus 2. 12 minus 12 is just a big old goose egg, plus 2. 0 plus 2 is 2. So we found that if I plugged in 2, we got a 2 out. Okay, and then if that's a 2, I know that this would give me a 2. So now we just got one more left. So now if we plug in a 3 into our equation, we'll have 3 times 3 squared minus 6 times 3 plus 2. Now we're just going to crunch out our numbers. 3 squared is just 9, so I'm left with 3 times 9. Negative 6 times 3 is negative 18 plus 2. 3 times 9 is 27 minus 18 plus 2. 27 minus 18 is just 9 plus 2. 9 plus 2 gives me 11. So we plugged in 3 and we got 11 out, and I know if I got 11 here, my 11 also goes right there. Now we can graph. So I start with my vertex, 1, negative 1. Then I went 2, 2. Then I went 3, 11. 1, 2, 3, 4, 5, 6. Other numbers for me. 11's right there. And then I know these guys are in the same matching spots. And then from here we can just connect. Okay, our domain, folks, remember it's always all real numbers. And our range, so it's going to be y. Now I'm looking at my graph. So right here, nothing's below it, right? So it needs to be greater than or equal to negative 1. So it's the same as this guy right here. Oh, and it's a minimum. There we go. I know this is a lot, and I'm really sorry. Try your best on your homework. Help each other out. Be good for the sub. And I will see you Monday, and we'll fix any issues that we don't know how to do right now. Okay? Oh, have a good weekend. Bye.